行，要不开始上课。那么again, briefly talk about yesterday. Um, Yesterday we have talked about functions, right? And briefly, a function means a piece of code that could finish a certain task. Sometimes you don't have to know what is in that box. You just go ahead and call it. All you have to know is the input and the output, right? Yeah, so for example, length function just got the length of the object, and you don't really know what's happening there. But yeah, and the syntax for defining a function is that you have this def keyword, and then this is a function name, and usually composed of different meaningful words, right? And with underscores, and most usually they're all lowercase. And you can have a list of parameters. You can have no matter how many parameters you want, right? Like doesn't really matter as long as when you try to call this function, you pass in whatever is needed, right? And then in terms of return, you can have more than one return statement. The function can end on different conditions, right? And that would make sense because for example, when you're trying to perform a task, and then there will be like different criterias that sort of tells you that you're finished, right? And this is the idea. And yeah, for function name, readability is the same as for validability is the same as variable. For readability, just make some meaningful names. Okay, for parameter list, you can have any number of parameters you wish as long as you separate them with a comma. Okay, and here we talked about the idea of formal parameter and actual parameter, right? And the formal parameter just means that whatever parameter is in here, we're just using that inside a function, right? And to use it as like a placeholder. And the actual parameter is just that when you actually try to call the function, then you'll pass in two parameters, right? In this case, two, right? And those A and B are actual parameters. And then it doesn't have to be variable. You can directly pass in like 6 and 9 and get past. So that is that. So here, if there is a return statement can take a variable, or it can also take an expression, right? For this mymax function, you can have this directly. So return x if x is larger than y, else y. Yeah, and then here teaches you. Yeah, here teaches you how to write documentation for a function. Um, in here, this function called mymax, this and then you just have a bunch of a block of comments right after this function, and then after you write something like this, you can do help bracket mymax, or you can do print mymax doc, and then it will just return you those. Okay, and in Java or C, you don't have something like this. So this is called multiple return values. It is basically the idea that you return like two things at a time. And then how do you try to achieve that? You achieve that by like the idea of packing of a of two numbers, right? Of a tuple, right? You basically return some and then in this case, sum divided by count, right? And then what it does is that it actually make it into a tuple and then return that tuple. And then as you can see here, I use TP equal to sum and average bracket my list, and then you once you print once you get that return statement, you print it out, then it gives you a tuple, right? And then this type here is tuple. All right, so we talked about recursion. Recursion just a function that calls itself, right? And then your sort of needs some return, base cases and recursion statement. So this is sort of like those two are base cases, and else you will just call yourself, right? And then that is called recursion step, maybe. Yeah, doesn't really matter. So those are base cases, and those are recursion step. Okay, so one typical one that you guys will definitely meet a lot if you go along on your computer science journey is that you can have this function called fib, right? And before that, so we actually learn how to do a fib in a while loop, in a for loop or while loop. Like it's just in the loop, right? It's the same thing. Yeah, and then this here is the recursion technique, right? And note that the for loop method or the loop method is faster than the recursion method, because we can. I don't actually remember what it is, but yeah, I mean, I don't actually remember which lecture it is, but like if we have some time today, then I will just sort of pull out those two algorithms, and maybe try to compare their performance when like the fib number is like 30 something or 40 something, right? And this is just an interesting experiment to see how fast the recursion method is and how fast the looping method is. Okay, so that is that. Yeah, so on top of my head, I will just say that the recursion will be so much slower because there is a lot of repeated calculation, and as the number goes larger and larger, the repeated tree, which is called like this is called repeated recursion tree, and this is saying those will grow larger and larger, so you're doing the same thing over and over again, which wastes quite a lot of time. Okay, and here parameter of the function, right? And we have this idea of keyword parameter, which just means that you can have those two parameter names, right? And then when you're actually passing in the parameter, you can specify which parameter are you passing in. So on default, it is positional argument. Positional argument. It just means that in whatever position you pass in, it will be assigned to whatever position that is in the function definition, right? So as you can see here, 3 is to is width and 4 is to height, right? And then you can also specify it, right? And then if you want to first pass in height and then pass in width, all you need to do is write the variable name, right? Like you'll have to just sort of let the compiler know, or what is actually doing, right? So here, and then you can have something like this as well. Even though it is not recommended, it is just means that you can use positional argument and keyword argument at the same time. But one thing to note that is positional argument always comes the first. Okay, So yeah, that is the idea. And you can have default parameter value. What that means is um, you don't have to pass in anything, and then it actually has a default value. So as you can see here, if I just do say hi without passing in anything, the function actually performs pretty well, and then with those default values, right? And also you can do a positional argument in here, but like you can only pass in one parameter because the other is already in default mode, right? So if you only pass in one string, in this case Alex, and then you just assign Alex to this variable name, and then you only have this hi Alex, and then the messages remain the same. So welcome here, right? And then you can also do this is just a normal way. You can just replace all of those default values with like those values you want, right? And then you can do say hi, and then Python is great. And then you can also do this. Use a keyword argument and specify what exactly you're passing in. So that is a good way as well. You can say a message, and then Python is great, and then the here name remains the same. Okay, and then this is not normally what you want, right? You're basically passing in a message to this variable name, which is not normally what we want. So avoid to do that, and just be careful of this idea of positional arguments and keyword arguments. Okay, and one thing to note is that default parameters need to be placed at the end, or at least like no matter how many you have, put on the right, put on the end side, right? And then leave spaces for those those actual arguments that needs number, right? Or not, at least not needs number, but like needs input. Okay, then it is easier, right? Because if you actually place those positional arguments in the front, then there is no way that you can actually do that, because remember the rule that when you're calling the function, the positional argument is always before the keyword argument. So you have to define it like this as well. Okay, and then yeah, those default parameters are pretty similar to this. Okay, so you can do this, print direct, and then you only pass in a character, and then yeah, and then it just prints out using that character. And then if you do it positionally, you just pass in another 6, and then so the height will be replaced by 6, right? And then you can use this keyword to actually get this length. So you just print yeah, no matter what this character is, the length becomes 10, and then this is sort of like a 5 times 10 matrix, right? And then you can just specify them both times. This is just trivial. And you can just pass in 10 and 10, and then this is a 100 question marks. Yeah, print rectangle, and then, yeah, you can. This is something you will do as well. So next is argument collection. So argument collection, you can pass in any number of parameters using this technique. And then just put a star in front of the formal parameter, and it will take more arguments using tuple. So it is basically saying that you can have um, no matter how many arguments that you want to pass in there, and then they will actually take it as a tuple. Okay, and then this argument collection, it can go on the end. It can also go at the front, But you know, when it's at the end, you can do a positional argument. But if the parameter is in the first one, if it is in the front, then to access this or to pass a value to this num, you have to use a keyword argument, because when you just connect it like this number 3 here will be treated as an element, as this tuple books, right? And then num does not actually have a value, and then it will give you an error of like you don't have enough arguments. Yeah, okay. So that is that. And then you can have this you can have this dictionary as parameters as well, right? You can have you know, those normal ones. You can have an argument collection, which has more than like no matter how many parameters there is, right? And then you can have this score, you can have this dictionary where you just specify it. Yeah, this is just like the fashion of you know, calling function dict, right? Remember, when you're trying to call function dict, you also write something like this, right? Python equals to 3.9, and then cpp is equal to 11, right? You also write something like this. Okay, so that is the idea. Did someone just drop out? Yeah, okay. Yeah, don't worry about it. Yeah, so this is the idea of parsing argument. And in Python, passing argument parameter is passed by value. That means that only the value will be passed, not the actual object. What happened is created a copy of the object and passed in, and whatever happened to that copy will never affect the original one. And then you can have this example when you pass in an int. You can pass in two ints and you try to swap them. On the main stack, it is not swapped. Okay, but if you sort of pass it in a dictionary and then you try to swap this dictionary, that actually works on the main stack. And this is not, this does not mean that this DW, this dictionary is actually passed in to that function. What happened is the main stack, the main function, when it's trying to call swap, and then it actually pass a pointer, which it does not really exist in Python, but you know, it just it just passed the address of this dictionary instead of the dictionary itself. Okay, and then once this swap function has the address, right? And this is like a copy of the key, right? It's like, sounds like 备用钥匙, right? You just create a 备用钥匙and then give it to someone, and then someone can have that key, and then you can enter your room and do the cleaning or do the decoration. And then once it's finished, then it is returned back to you. So it is still passed by value, but it can actually affect things on main stack, but it does not change the fact that it is passed by value. Okay, so exercises. I will give you guys like 5 minutes to actually go through the exercise and think about how we should implement this. And then once once 5 minutes is passed, I'll come back and then take up those questions. Okay. All right. So yeah, 5 minutes. So I'll wait 1 more minute and see if you guys have questions before I actually start talking about those. Have you guys at least try yourselves? Okay, so yeah, since there's no questions, I will keep talking about it. Um, write a Python function checks whether a passed string is a palindrome or not. Okay, so this and to interpret this question, there is lots of different ways. Probably you guys don't have the same solution as mine, but that is okay, as long as your program is doing the correct thing. I'll be happy with it. Okay, and write so. What is a palindrome? A palindrome is a word, a phrase, or sentence that reads the same back, forth, and forward, right? And then yeah, you can have this input for madam, right? And then you can have this called nurses run. But like yeah, it's sort of needs to be one world. Okay, and then what I have is I have this. So it is a simple way that I that because the idea is we can treat a string as a list, right? Okay, yeah, we can treat string as a list, and what happened is in the list there is a function called reverse, right? And then, for example, if I put madam here, madam, so uh, oh, I forgot this printing. Okay, um, yeah. So once we just assign it into two different lists, and then I call list 2 the reverse. And then if I am trying to compare if list 1 is the same as list 2. Okay, so this is the idea of how you solve this. There's multiple ways. There is like the string indexing ways, where you just for you just do for loop and then loop the entire string, or maybe you don't have to. You just loop the half of the string and then using index, and then you check if string at position index and at position length -1 minus index are the same character. Okay, understand what I'm saying? So like yeah, that is the other solution. So you can have like for I in range then of string divided by 2, and this divided by the 2 means that it can be an integer division, because when it's odd like this, So you don't have to check. You don't have to check the character in the middle, right? You only have to check the first one, the last one, the second one, and the second last one, and then whatever is in the middle, it can remain in the middle, because it does not affect um, the validness of if it is a palindrome, right? So you can have some sort of thing like this, and then you just do s if si is equal to s s len s minus 1 minus I, right? And then you just in this case, you'll probably do not equal, right? And then once you have this not equal, then you just return false or something, so that is the other way. But I am pretty happy with this way. I mean, this will get your hands dirty, playing with those indexes. This looks pretty simple. It has a built-in function with reverse, and then all you have to do is create two instances of a list and then reverse it, and try to compare them. And during I write this solution, one mistake that I made is that I was trying to do something like this. Look at this. So instead of this, what I did was I do L2 is equal to L1 dot reverse, right? It's sort of making sense, right? You're having a L2, and which is the reverse of L1. It makes sense to in terms of syntax or whatever. But once you try to do that, you can see this L2 is actually none. And what happened is L1 dot reverse, it actually only reversed itself. What it means is that the thing that gets reversed is L1, okay? And then this will show better if you do AABB, something like this. And then this L1 is actually reversed to BBAA, but L2 is still none, okay? So just keep in mind that this method actually, do some actually takes at that place and exactly the place you called. So whatever variable you use to call this function, it happens to that variable instead of having a return type, having a return value, which is like the reverse of the list. So that is something to keep in mind. And all right, so that is it. That is everything that I want to talk about for this exercise. Okay. Any questions, concerns, or blah blah blah? Okay. As usual, I don't see any questions, so I will just go on. Yeah, and then if there are actually any questions, go ahead and interrupt me. Okay. So this exercise, write a Python function that takes a list and returns a new list with unique elements in the first list. I mean, yeah, this is basically the same thing as like one. I don't remember which lecture it is, but like there is a exercise in the previous lecture which does exactly the same thing, and this here just yeah, more or less the same, but just using it in the functional fashion. So it actually be like implement it as a function, so you can get unique bracket li, and then once you pass in this, and then the output will be 1 2 3 4 5. Okay, and then yeah, in the question it actually says returns a new list, so don't bother to like replace the manipulate the original list. Okay, so that is that. Any questions? Okay, so that one is I would say fairly simple. Okay, so write a recursive function to calculate the function the sum of numbers from 0 to 50. I mean, this one is pretty simple. This one is the easiest recursive function that I can think of. It basically does the add, right? And this is sort of like a summation. We can easily do that in a for loop, right? And so just this one, yeah. I think someone asked about this assertion. So what this assertion means is that, for example, I am just trying to do a little bit of validation here. So if I do not pass in a list, I pass in like a number. What will happen is you'll get an assert arrow. This basically means that you're taking in this, right? So number 284, right? Is put it into this variable li. And then we are asserting that this is an instance of list. So is instance, if you're curious, you can actually look up this, look at this function, right? And it is okay to look up, and it is a good habit to always look up that function that you are not familiar with and figure out what is happening. So here, it doesn't actually give you a definition, it just gives you how it works. Okay, oh yeah, here is the definition. So check if the number 5 is an integer, right? So you can do add x equal to as instance 5 comma int, and then this is the actual instance that you want to check. This is the type that you think it is. So is instance function returns true if in specific object is a specific type, otherwise false, right? So if a type parameter is a tuple, this function will return true if the object object is one of the types in the tuple, right? So if you do some object here and then you write tuple, and then if it actually is a tuple, then it will give you true. Otherwise, it will give you false. Okay, and then you can try to sort of oops, this is the wrong slide. You can try to do a assert, right? This is sort of like an input validation, right? You don't have to do this because okay, yeah, you don't have to do this because this is something that it is not really required, but it is a good habit to always check. And yeah, once you accidentally, when you deal with a large code bases, when you accidentally put in something, right? And this is always a good thing to check, right? So like this function is actually taken in a list, and then we're gonna make sure that this is a list before we do anything, because we are trying to iterate through it, right? And then think about if I do this, right? And then oops, I have to cut this again. And then if I do like a number like this, right? And then it will give me an arrow because a number is not iterable, right? int object is not iterable. You're trying to iterate through the list, but this is not a list, you know. So yeah, this is always a good thing to check and to keep in mind. Okay, so that is this assertion do. Yeah, 1 second. I'll just reply to Jennifer. Okay, so yeah, the last one that I want to talk about is this summation using a recursion. So def sum of number, and then you just put in the maximum number, and then I'm just trying to do something like this. Asserted the input is an integer. That wouldn't usually have any problem, and then you have a base case here, and this base case, imagine it is not there. It will actually maximum recursion depths exceeding while calling a Python object. What does that mean? That means it is keep recurring and recurring and recurring. And if I try to do something like this, print max num, right? So it actually prints out how many times it recurs. And look at that. There's no end, right? It just calling a recursive function again, again, and again. And then it never ends until it is giving you an arrow. So that is what a base case is. And then, sometimes when you try to write a function, if you forget a base case, then this is what will happen. Okay. And then this base case here just means that it is there to terminate your program. And this is the end of your program. You're basically indicating it, right? So this is the end. Do not go further. If you go further, then the police of a compiler will come and arrest you. Okay. So yeah. So if I try to print max sum, you can see that 50 is being called, 49, 48, blah 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 blah, and then you just add it, and then here here's the result, right? So that is what we want, and you can also try number like 100, right? And as you can see, the if you add 1 to 100, then the answer will just be 50-50, right? And just be wooling, right? Like this is just a normal thing. It is just easy stuff to check. So yeah, this is the example of how it works. And the recursion step is what? So think about this. When you're trying to write a recursion step, then you'll try to write an expression, right? So f in this case, sum of number bracket 50, right? And then what will do if you have sum of number 49? You have the value of sum of number 49, which is here. And then if you want to get sum of number 50, you just add this max number, right? So like this max number. So when you're actually trying to call this function, you'll pass in the number 100, right? 100 is here, 100 is not equal to 0, and then you return sum of number 99, right? 100 minus 1 is 99. You have sum of number 99 plus 100, right? And then you go ahead and further calculate this sum of number 99, right? And then sum of number 99 is sum of number 98 plus max number, right? Which is 99, right? And then so go on, so on and so forth. And then yeah, sometimes writing recursion will needs a little bit of practice. You have to sort of figure out the initial state and the recursive step. Okay, so that is something that keeps in mind. Okay, so yeah, I am actually taking quite a long time to review. Is there any questions before I actually move on to actually today's lecture? Questions, concerns? Feel free to talk in the chat. And if no, okay, sounds good. Right, so I am assuming there is no questions. If there is, go ahead and ask if you're currently typing. But yeah, so lecture 7. Lecture 7 in here, we talk about the scope of a variable. So since we have introduced the idea of functions, right? And then we sort of have an idea of memory. We also have an idea of memory, like pass by value or the main stack, or if you use an analogy, which is like a room or something, right? And then this idea is very important here. So the scope of variable. When you try to access a variable that is out of its scope, then you cannot access it, right? It is mainly saying that, for example, you are trying to find your computer in your living room, but the computer is actually in your bedroom, right? So this is the idea is something like this. Oops. Yeah. Okay, yeah. So that is that. So you're trying to find something that is not in your room, then you cannot find it, right? So yeah, here there are two types of, variables in terms of the scope. One is called local variable, and the other one is called global variable, right? And local variable just means it is inside sort of one sort of function, right? And then global variable is that it is not in any kind of function. And that I will definitely illustrate more once we actually talks about like objects and those kind of stuff. And then talks about like the main function in Python, because in other languages we all have main function, and in Python it is sort of like you just start writing things, right? And then this is not quite normal. At least I am a so in terms of programming language, Java is my first language, and I first deal with Python. I don't see main function. I feel uncomfortable. I don't know if you guys feel the same, but that is what I feel when I just started. Okay, but yeah, so the function, you can treat function as like a temporary storage room. It is basically like you are in the living room, and then if you call a function, you temporarily go to another room and do your thing there, and then leave your thing there and only bring back the return value. And then whatever is left in there, it is later deleted by the operating system or the compiler. Okay, and here in Python, there are 3 helper functions to get the list of globals or locals. And here, so one is globals, which gives you the global variables, all the global variables. Locals means that it will give you all a dictionary of local variables. And be careful, this here is in the format of dictionary. Okay, and then bars and an object. So since we have not talked about objects, we will not elaborate on this a lot. But what this is doing is that you just get all the variable that is belong to an object. Okay, and then if note that if you don't pass in any parameter to object, so if you don't pass in anything, basically you write vars bracket bracket, and then the vars are the same as locals, because it is sort of like taking the current scope. Okay, and then there's a difference between locals and the globals. Locals actually 就是获取当前范围的 variable dictionary. So if you run locals inside of a function, then it will return that any variable that is created inside the function. But if you run locals outside of any function, that means the current scope is global, right? Like you understand what do you mean? What I mean? So basically, like locals 就是比如说get 所有的在某一个房间里的变量，好吧？那么如果你在一个 function，那就是说你在一个temporary room 里面，那么这个 room 你 get locals，那就会 get 那个 room 里面所有的 variable。但是呢，如果你现在在 global 的环境里面，比如说living room 是 global，那么你现在如果待在 living room 里面，你 call local，那么就和你 call global 没有任何区别，懂吧？ Okay, and if you're not clear, then there will be examples to tell you more. Okay, here in Google Colab, there is too many global functions, so I will branch out to a repo page. And this repo page has exactly the same code as I have in this code box, but this repo page is just a better way to illustrate. So what happens here? Okay, first things first. When you try to analyze or when you try to read a Python file, I would say sometimes you just forgot forgot the definition of function for 1 second. You're trying to find out what is happening here. So here everything here is globals, right? And then everything here is a local function. This is basically saying that this is the living room. This is, maybe one of the bedroom. Okay. And then x is equal to 5. Okay, good. And then we call test. Okay. Then in test, we have age is equal to 20. Then that is a local variable. We call print age. Then we can have the value for age, and then print locals just gives you this, right? Just gives you a dictionary with age is equal to 20. right? And then you can also call this, since this is a dictionary, then you can access it using the fashion of dictionary, right? So you just use the square bracket, and then you try to access that. And yeah, maybe if you're not sure with whether you have that variable, use the get method. Remember that get method is stronger than the square bracket notation in terms of if the key does not exist, then it will not give you an arrow, but it will just give you a none. Okay, and then yeah, that is actually a review for a dictionary. But yeah, you can sort of change that value and try to print that and see what's the outcome is. And then in this function, it also deals with globals. So in this function, it calls globals with x, and then you're trying to assign values to this x. And in the following print, you will see if it successes or not. Okay, then yes, this is sort of the overview of this test function. And then we continue. So y is equal to 20. Okay, and then print globals, and then print locals. And yeah, you can see if there is any kind of difference, right? And then you just print the value of x, you print globals x, and then you try to modify x with globals, and you try to modify x with locals, and sort of see if any of those works. Okay, so once I click run, and there's quite a lot of happening here. So x is equal to 5. Oops. X is equal to 5. That is no problem. So then we go into text function, right? So age is equal to 20. Print age, it gives you 20. Print locals, this gives you a dictionary of age, and then you just access it. Okay. Locals age is equal to 12. Okay. It is sort of assigning the value for a local variable, and you try to print that again. Interestingly, that did not work. So yeah, I think in Python this does not work. So you cannot assign or update a value to like a local variable. Okay, but so here globals x is equal to 19, and then globals z is equal to 21. So that is the end of the test function. And then we're coming back to this global. Okay, so we have y is equal to 20, and then I print globals. And here there are a whole bunch of things. You can definitely ignore it, but if you're interested, you can take a look. It has like this main function, doc is equal to none or something something, and then function test at blah blah blah. This is basically this function, right? Yeah, remember that function is actually can be treated as a variable. I don't know if it's yesterday's lecture or today's lecture. Yeah, it doesn't matter. Function can be actually treated as a variable, and then you can assign it. You can try to assign it to like a variable, right? But yeah, here x is that's today's lecture. But yeah, x is equal to 19, z is equal to 21, y is equal to 20. So this basically means that this works, right? You can assign a global variable in this fashion. This also works because z is already added in there. And then the second print function is just there for you to see that in this case, in global, if you try to print globals, or if you try to print locals, it gives you the same result because you're basically staying in the same place, right? And then yeah, globals always goes to, maybe living room. And then if you're in the living room and then you're calling, which room it is, or give me all the variables in this room, then it is the same thing as globals. Okay, so then we just print x, and then we can do the value for x, right? And then globals, print globals x, and then this works as well. Globals x is equal to 39 is trying to assign, change the variable using that dictionary. And then if you print that, this takes place, right? And be careful of this. So if you call locos at a globos at the living room, I would say, if you try to change that variable, it actually works instead of like comparing to this in this test function. Changing local variable does not work, so that is something to keep in mind. Okay, so this is this short example of globals, or sort of to access or to change globals or locals. Okay, so that is that. Yeah, if you're curious, you can look through this as well. This is pretty long, and yeah, I don't even know what's going on there, but yeah, you can see this function here: x is equal to 5, y is equal to 20, some blah 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 stuff. Yeah, so that is what is happening. Okay, and yeah. Oh, I see. This code is slightly different than I would actually copy this and then paste it here so that it keeps consistent. Okay, here. So if you scroll, yeah, this is the same thing. So you have x is equal to 19, that is 21, y is equal to 20. Okay, so next. So after we talked about this, there is an idea. What if, look at this piece of code. So name is equal to Charlie, definition test, print in function name, and then if I don't write this, and then I do test, and then I do print. What happened is, okay, so it seems to be pretty good. You can sort of access this variable inside a function, which is sort of nice, I would say. But if you try to assign it, oops, if you have another variable here, try to say like name is equal to Ray, and then that will give you a arrow which says local variable name referenced before assignment. So once you have this, then this print function is actually yeah, this name here is actually referring to this variable, and then this variable is accessed before assign. Okay, and then we can actually do a little bit of experiment. What will happen here, right? So yeah, in function it will say Ray, and then you print that out, and then you do that here, and then you print out name in the outside, and then it is still Charlie, right? But here is a problem. So what happens if you sort of, for example, you need to access this function, right? It is it is a global variable, but inside of a function you cannot access it. It is really stupid because in Java and C you can do that easily. Yeah, I mean, just kidding. So yeah, if you have designed a similar a variable with the same name, then it will just automatically refer to the local variable here. And if you want to access it, then you will need to call this. So print in function globals and then name, right? Using this code piece from here, you can actually use globals. Globals is a dictionary. You can access its value by providing the key. Okay, and then no matter what you put here, it does not matter because in the print you're printing the global variable, and then here you're also printing the global variable, so that is fine. What you can also do is this. What if you want to modify you know the global function, or the global variable, right? And then what you can do, I mean, of course, if you want to do it like this, so globals bracket and then using the dictionary fashion, I believe that is definitely okay. Like that is definitely doable. But here is the keyword called global, right? And then this is basically thing that this variable that I'm using here is actually the same as this variable here, global, or this variable name here. So this global name is the same as this one. And then if I print name, name is equal to Ray. So in function print name, then the function will be called Charlie, right? Because the name was originally Charlie. And then I change this name to Ray, and then I print it outside of the function. um, it will actually be changed. It will actually print Ray instead of Charlie. So that is the use case for global. So it actually declares the function inside, declare the variable inside your function, and then tell the compiler that this is actually the function, the variable that is global, instead of I just created one. Okay, so that is what is happening. Okay, so more advanced on that, local function. What is a local function? It is a function inside a function. I forgot if there is techniques in Java or C++ or C have anything like this. I do not think so though. But yeah, so this is a function inside of a function, and you can define it as this. For example, square is you provide a you provide n, and then you return n times n. And then cube, you just multiply three things together. And then factorial, it is just that you just multiply and equal all the way down there using a for loop. Okay, that is three easy functions. And then this is a outer function, right? So you can have get mass function, and then you can provide type, and then so this is just the number the number that you want to pass in. So if type is equal to square, this type here, this is a variable that is equal to square, then you return the result of this. So basically you do return square bracket nn, right? And then this is the expression, and it will be evaluated, right? So it is basically saying that return the result of square bracket nn, right? And then you just pass in, for example, if here is number 3, then you just pass in and then as 3, and then here n is 3, and then you will return question expression, return it as 9, and then this whole expression is 9, and then you further return to this entire to here, and then being printed. So this is 9. Okay, and then the same thing happens here for cube, and then else return factorial, right? And then if you do like factorial, then you can pass in 5, and then 5 factorial is 120. 120. Oh yeah. By the way, if you guys do not know factorial, yeah, factorial means, for example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Okay. And then anything factorial just means that you just multiply that, and then multiply minus 1 minus 1 minus 1 all the way to the all the way to 1, right? So it is sort of like a summation, but it is in multiply. It is using multiply, right? Okay, got that. Yeah. All right. So that is the use of local function. And then the problem is, if you have a function called full, and then you have a name called Charlie, and then you have another function bar, and then you try to print name, okay, it works okay. It is called Charlie. If I delete this and then try to say name is equal to Ray, then the same thing will happen, right? So it is basically referencing to this name instead of this one, right? And then if I move this above, then it is still gonna reference this variable name, which is Ray, right? And what we want is we can introduce this keyword. It is pretty similar to global, except that it is used in a function of functions. Not gonna say function of functions, but like function inside of a function. Okay, so here name is equal to Charlie, and then def bar, you do non-local name, and then print name, and then name is equal to Ray, and then in the function full, you call bar, and then bar is executed, and then you print name. Okay, so okay, so what happens is the program flow is this is the definition, so we ignore it. The first we do function full. Okay, so function for is like this: name is equal to Charlie. Okay, we'll punch a name, and then this is the definition of a function, so we ignore it. We call bar, so bar is being called. Then you have non-local name. Okay, so I know that this name is actually talking about this name, right? And then if you yeah, let me continue on that. So this name is actually equal to this name, and then you try to print name, it will give you Charlie for sure, because those two names are the same. And then name is equal to Ray, and then this value is modified, and then you try to print name, and then this Ray is here. And then you can actually do something like this if you're really bad. Yeah, and then you can have a name here called Alex, and then you can just print name. And then what happened here is that Alex is not affected, right? So non-local name means that this name is actually referring to this, and then you can have global as well. Global name. Then what is happening here? Okay, this is yeah, I mean, this is new to me. So let me actually analyze it. Okay, so name is equal to Alex, and then you have def, so you have this function call. Okay, so name is equal to Charlie. This bar here is basically global name, right? So global name is actually referring to this name here, right? So if you print name, then yeah, I mean, if you print name, then it is just this, right? And then you print Alex, okay? And then name is equal to Ray. And then you print name. It is, oh, name is equal to Ray means that, you know, you have changed the value for this global function, right? Like, not global function, sorry about that, global variable name, okay? And then, you know, this value is changed, and then you print name. This name here is this name. Okay, and then you try to print name, and this is not Alex anymore, it is Ray. Okay, so yeah, as you can see, this is you know, sort of I mean, it is going on you know, different loops, and not different loops, like 就是你有可能会绕进去，对吧？但是如果你就是 analyze that line by line, then you know, it is not so much a big deal, right? And then yeah, got it. So this example here is I just want to show you the difference between global name and then non-local name. Non-local name. And yeah, oops. Yeah, I just want to make a comment here that if you don't use the function, the variable names that are exactly the same, then we are fine. Okay, but like, yeah, it provides you a way to access variables that are not in your scope, or let's say not in your room, right? And then you can read it, you can modify it. It is a good thing to know, and we will probably use it sometime or not, right? Like this can be important. Okay, so this is that. Advanced function technique. So above that is basically everything that you need to know about function. And then if you want to get more advanced in function, no, I mean, this is not saying that this is an advanced function course. Okay, this is different. This is different as this is different. This is different between grade 12 advanced function course. Okay, so yeah, don't think of I am teaching some math here. I'm not. Okay, deal with derivatives yourself. Okay. Okay, so that's a little joke. So advanced function technique. Those ones that I described above are pretty basic. When you know how to get more advanced in functions, then you know, programming will be more easy than it was before. Okay, so in Python, function can be a variable. Okay, got it? All functions are a function object, and you can assign a function to a variable just like assign an int, a float, a list, a tuple, a string to a variable. Okay, so this is, I don't know if it's something new. I think in JavaScript there is the same idea of variable as a function. Yeah, so the idea is you can assign a function to a variable, right? And then you can actually call it, right? And yeah, so I will just give you an example here. Let me just print type myfunc. Okay. So yeah, you have this def power. This power function is just basically means that you know, you have a base, you have an exponent, and then you're just doing base to the power of exponent. Okay, and this is just simple function. I'm not going to explain it. My function is equal to power, which means that this variable called my function is now a functional variable. It is a function variable, right? And then if you try to print the type of this variable, then it will give you a class function, right? So, and then what happened is you can call this function, right? You can call this function call print my func brackets 3 and 4, and it actually prints out the value for that function. Okay, and then def area, you know, just calculates the area, and then you can further assign my function to area, and then you print the same thing. It'll give you a different result because now the function has been changed. Okay, so with that in mind, I would make a comment that you know, it is more important for you guys to know what kind of data you're dealing with, or what is actually inside the variable. Okay, when your program was like a large code base, then this will sometimes be difficult, like because there is no type in here, the idea of type in here, you don't know when the type is changed. Okay, and then you know, like this will happen, and then it needs to be treated with, you know, extreme care. Okay, so this is just common. And here, use a function as a parameter. Okay, so since that you know, you can put a function into a variable, then you can definitely pass a function, right? Yeah, so in this case, this function is called mapping, right? And basically has a data, you know, it's a bunch of data, and then you have this thing called function, and then this is basically a function variable, right? And it has a function in it. Okay, so it is basically like, think of function as a tool. For example, um, the function is a chopstick, okay? And then I pass you a bowl of rice and a chopstick so that you can eat. And then after that, you just give me the empty bowl and the chopstick. Like you get this idea? So like the function is basically a tool for you to do things. And then this function here, data comma function, is basically means that whatever you need in that function, I will provide it for you. Whatever you are using, like whatever technique that you're using, or whatever tool that you use to eat, I will also provide it for you. What you need to do is to just eat. Okay, so that is the idea. So here, those are the same square, cube, factorial. We have defined it in the previous code boxes, and then you know, there's nothing wrong with define them again. So it does not affect anything. Instead, other than you have to type it. But yeah. So data is equal to, for example, 34958, right? And then you just print raw data is to something like this. And then you have a line break. So you have mapping, right? And then you have this list of data. And then you have this function called square, right? And then in this mapping, you say result is equal to an empty list. And then for every item in the data, you would result append, and then you call this function fn bracket e, means that you are doing a function for each data in the list of data, right? And then you append that to the result, and then you're just going to return the result. And then you basically do the same thing, right? And then you know um, then this result is 9, 16, 81, 25, 64. Those are squares, right? And those are cubes. Those are factorials. You can see the factorials grows really quick, right? Yeah, just ignore this, or maybe you can do this because there is a overlap between this map function, because there is a built-in Python function called map, and we are doing similar things here, but I'm trying to avoid using the same name, because it will confuse the compiler about it. Okay, and yeah, so that is use function as a parameter. Same thing, use function as a return value. The same thing. So mass.function is equal to get mass function, and then if you pass in cube, then let's say type is equal to cube, and then return cube, right? So this function is actually being returned, and then you assign it to this mass function, and then if you call mass function 5, then you're basically doing 5 cube, which is 125. Okay, and then you do the same thing here. You call square, and then you have this 5 square, and then if you call other, then it will have this factorial, right? So that is passing function as a return value. Okay, and then now we are going to talk about lambda expression. So what is lambda expression? Sometimes function names does not matter anymore. But I say that, what does that actually mean, right? So look at this. Look at this. Look at this previous example. Okay, so if you have some function like this, so you have 3 functions like this. You have def square, def cube, def factorial, and then you're basically just returning this function definition. But the important thing is, when you get outside of this specific function, nobody is, because those functions are actually not open to anyone, right? And then if those functions are easy enough, then this lambda expression comes into play. The lambda expression is just a one-line function definition, and you don't have to provide name and all those ugly formatting to this expression. This expression basically says that you have this keyword called lambda, and then you do n, and this n is the input of this function, and then you do column, and then this is the output of the function. Okay, the syntax is lambda and then parameter list. Parameter list is separate by comma, and then you have expression to return. Okay, so as you can see here, the above thing, this is pretty long. You are trying to define a function, and then if you have a specific type, you're just pass back the corresponding function, right? And then if you do something like this, then you can return lambda n, and then return n square, right? And then lambda n cube, right? And just be careful. Sometimes you know, a function is too complicated for a lambda function, because you know, because this you have like a sort of for loop here and whatever is going on there. So this one is, you know, not that simple, and which means that it is, you know, not a good thing to put in a lambda function. Or if you are so familiar with the language yourself, you can try to do it, but it is not recommended. Okay, so yeah, it means that if you have like lambda function are used for two purposes. The first purpose is that you know, it is a short form of writing a function. Okay, with, you know, one line of code, you can define a function and then pass it back. Okay, so that is the good about it. And then another good about it is that you know, for those functions, you don't really care what those function, like, you don't really care the name of those function, because outside of this get mass function, nobody will know that what those function are called, right? Because those are local variables, right? Those are local functions. So what you can do is you can just return a lambda expression, right? It is a quick prototype of a function. You can directly pass it back. You don't care about the name. You only care about it actually does what you want, right? And then yeah, you have other case. This other case just calculates the arithmetic sum. Yeah, I think it's the arithmetic sum, but it does not matter. It's just there to give you an example. Okay, so this is lambda expression. Okay, and then what you can do with this lambda function. So the thing we talked about, map. So for those of you who do not familiar with map function, I believe most of you do not familiar with it. So you can have a function. The map is a built-in function. The function returns a map object, which is the iterator. We'll talk about iterator later when we're doing classes and object-oriented, which is tomorrow. Yeah. So yeah, the results after applying the given function to each item is of a given iterable, right? So you have a function, you have a iterable, which is like string or list or whatever, and then you are just apply this function to each of the variable, right? It is a function which map passes each element of a given iterable, right? And iterable is, it is a iterable which is to be mapped. Okay, so that is the map. Okay, so so yeah, map here. So remember, the first argument is a function. The second argument is a iterable. Iterable means you know, you can think of it as a list or a tuple. It is basically that you know, an object that you know, you can use a for in loop to loop through it, right? So yeah, that is iterable. So yeah, in this case map, you can say lambda x, and then x times x, and then it just means that you can change the variable here, right? And you can say lambda y is y times y. It doesn't matter which variable you name, right? Yeah, and then after you do this, then it actually calculates the squares from 0 to 7, right? And then yeah, so map lambda blah blah blah, and then you provide a range. And then what this is, right? You might curious about the type of X. What the type of X is? It is a class of map, so it is a new class. And then if you try to print X, what will happen? What will happen is it doesn't actually give you all the thing. It just gives you like where it is, where the object is. And then the way you loop through it is you can have this. So this is a one line list expression. Okay, what happened here is that you have a list, right? And then here is the expression. Okay, so it is basically saying that I put this result of this expression into a list, right? And what that expression is E. um, it is, each item, right? For E in X, right? So it is a list of E for E in X. Like you can understand it. So like you iterate through X and then put every item um, of X in the list. Okay, so this is doing the similar thing, except that you can also have a expression like this: X times X if X percentage by 2 is equal to 0, right? So it only gives you the odd ones. Oops, I think is there something wrong with this? No, probably not. Yeah, it does not. It does not actually change anything. So yeah, so it will be x squared if x percentage by 2 is equal to 0. Otherwise, you do so like for those odd terms, you just do 0, right? Because you have x x times x if blah 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 else 0, right? So like with those stuff, Python expression, like one line Python expression can be really long, and sometimes if you're not very familiar with those, it can be challenging to read. And because of this is the flexibility of this language. I mean, it has pros and cons, right? And sometimes for starters, it is very difficult to read those, and because it is too flexible. Because and then you sometimes do not know what you should do, right? And for advanced users, they might think that this is really great, and I can write everything in one line. I feel like this is very efficient, right? And then yeah, so that is that. So yeah, that is pretty much it for today's lecture. I will give you 3 exercises, and I will try to experiment the for loop of Fibonacci and the recursion of Fibonacci. And then we're going to watch a short video of, wait, where is that video? Oops. Okay, did I not save that video? Okay, yeah. All right. So I guess I will need to try to find it. But yeah. So that is my plan here. I will briefly go through the exercise. So yeah, print all factors of a given value. So write a function, right? So let me elaborate here. Write a function um, factor uh, to print all the factors of a given value, right? And factors are like 1, and then if you have 1 and then you do 10, right? And then if you have 2 and then you just have 5, right? And then those are just all the factors of a given value. And then one good thing is that you do not have to sort it. It just gets 2 factors at one time. Okay, so that is that. And here, write a function called convert to Fahrenheit, which takes a Celsius temperature and converts it to Fahrenheit, and returning the answer. Write the code that calls a function 3 times to convert temperature 0, 32, and 100 to Fahrenheit, printing the results each time. Yeah, yeah, those outputs should be blah 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 and blah. And if you're not familiar with Fahrenheit, go Google it. There is just a formula for you that you can use, and just use that formula, and that will be easy. Okay, so that is that. And the other one is sort a list of string by the third character of each string using a lambda function. And that is very specific. Wait a minute, it doesn't save my work. Okay. um, yeah, anyways, for example, you can have a input list, which is equal, maybe something like, yeah, so in terms of this question, as long as each string is larger than like 3 characters, we'll be fine, right? So yeah, let's say apple, uh, peach, watermelon. Every time I type water, I want to type Lou. Okay, that's what a Waterloo student will usually do. So forgive me about that. Uh, what else? Toronto. Yeah, so some stuff like that. It can be random, right? Doesn't have to be instead specifically this strange and this list. And you can give yourself some weird test cases, like the third character is a number or is a lowercase or whatever you want, right? All you need is your program is working. So sort. So this is the hint. I provide you with a link that actually gives you list sort. And then when you see here, you can see there's two stuff that actually does the same thing, but does not really matter. And yeah, and you have to note that sort actually changes the list, but sorted is a built-in function as well, and the sorted just returns whatever the outcome is. Okay, and then the thing that I want to talk about is key. So the function that serves as a key for the sort comparison. So this is a little bit more challenging. You can read through this post and sort of
look at how this is being done. And this question asks to use a lambda function. Okay, so this is a good way for you guys to practice lambda function. And like in reality, if you have those function like this, so like for example this map function, and for example this here, this sort function, sometimes you just not care, like you will never use it again after this, right? So it would make sense to use a lambda function, right? To actually declare once and then toss it forever, or yeah, some idea like that. So that is the idea of exercise. Yeah, because sometimes if I don't run it, then I don't think it will be saved. Okay, so restart and run. So that will be saved. Everything will be saved. So that is that. In terms of video, I will show you guys later. And I will just want to make a, I want to actually find this Fibonacci, let me think of a way to do this. So where is that Fibonacci? Yeah, so if you yeah, I mean, if you're not interested, you can go ahead to do the exercise, but you know, this is something fun to watch. Okay, I promise you, this is something fun to watch. Okay, so okay, I accidentally closed this one. Okay, so what I will do, computer is lagging so much. Okay, what I will do is, okay, so which, yeah, let me go to my Google Drive and see which one is Colab notebook. I think it's lecture 5, right? Lecture 5, there is a while loop implementation of Fibonacci. Yeah, I just want to copy the code. I don't want to write the code myself, even though I can. Like, you know, sometimes programmers are just lazy, and that is what programmers are. Anyways, I'm gonna write it myself. It is fun to watch me making mistakes if I do. But yeah, for a Fibonacci number, just do A is equal to 1, B is equal to 1, while for I in range, for example, 40. This is so if I percent 2 is equal to 0, then print A, and then A plus equal to B, and then you basically do the same thing here. All you have to do is else, right? Oops, no, this is what I want. Print B, and then B plus or equal to A. See how fast the heck it is. This is 40, right? And it is pretty much done in 1 second, or less than 1 second. How long it takes? 0 second. I don't know how like I don't know how fast it is, but you know what I can do is time module Python. You know, sometimes you just look it up. Okay, so there is a time module. As I remembered, you can get time, and then you can import time and etc. Right? So you can do, yeah. I don't know if you need to import time. I'll just do it. T1 is equal to time dot get GMT time. T2 is equal to time dot time. Then print. I am not actually sure if this works, but I'll just see. Okay, so I am just gonna comment out this print statement. Okay, this does not work, but I will just print them out respectively so that you can get an idea. There is there is no difference. Okay, so you can say that it is finished within a second with range 40, right? So range 40 is doing 39, right? So print fib 39. And I will also do this. It's stuck. Okay, yeah. I don't know if you guys have the patience to wait. But I mean, the performance is clear enough. Okay, the performance is clear enough. For this one, I have not yet finished it. Okay, I have not yet finished talking, and you know, it is done already. So as you can see, the performance is self-explanatory, and I'll just print fib 30. Oh, okay, yeah. Print fib 30. Yeah, I would just sort of again need a loop or some sort of idea for I in range 31, right? And then print fib I, right? Then you're just sort of having this idea, right? And then I'll print A, print B, then don't delete everything. So yeah, I don't think you need this time thing anymore because it is self-explanatory. Okay, so oops, this is still 40, 31, 31, right? Oops, I think this is 30. Oh, because this has one more term. So yeah, I would just do 30 here. As you can see here, this number is the same, 514229832, right? 5142298322040, right? So as you can see here, this is the same, right? This result is the same. This is so much faster than this one. And this idea, this looping idea, is actually called dynamic programming. And as from this example, you can tell that if you have a question that requires you to do recursion, I mean, it is easy for you to write. I mean, I would say this is definitely easier to write than this. But like, if you can see me easily writing it, but like you sort of needs to memorize. Sorry, zero division arrow. Okay. Yeah. 1 second, I will come to this. So yeah, I mean, as you if you can this iteration is definitely faster than this one, but this one is harder to think. Okay, so is factor. Oh, okay, you guys are already doing this. Okay, good. I like this. Someone gave to me this piece of code, and I will oh, oops. It's not copy, paste. Okay, so is factor num. Okay, you have a list. Okay, for sure. For I in range 0 to num plus 1, that's good. If num percent by I is equal to 0, answer is append I, and then else break. Okay, it seems like, look at this. If I comment all of those out, then I do print I, what will happen? It happens when, so the iteration of this is, did you see the problem already? For I in range 0 to this, but if you use num and percentage by 0, did you remember that the fact that if you do percentage by 0, there is a problem? Like if you do percentage by 0, then it will give you a zero division error, right? And if I give you this and run this, it will give me an error because the first iteration I is 0, right? As you can see here, integer division or modulo by 0. Yeah, so if you want to specify the range, because what we usually do is we start from 0, but instead, specifically in this case, we would want to, okay, you still have none. Yeah, and there is, yeah, no, print. Yeah, this is the problem. You are printing it, but it is not. Yeah, in terms of the range, it should be 1 to num plus 1, right? And this print thing, you need to be pretty tricky. You need to be pretty careful. So this answer here, answer dot append I, this expression does not give you any kind of return value, right? And then if you really want to print, what you should print is print I, right? Instead of, oops, you have to indent it well, and probably it's because of the editor. But here, what you have to do is print I. And yeah, look at those. There is still bug to deal with. Okay, yeah. So apparently, this answer should not be something like this, right? And then you have to think about if your condition is right, right? So yeah, think about it more. I will not yet reveal the answer, and I'll give you some time to think through it. Okay, sounds good. Yeah. Okay. So yeah, with the problem, yeah, percentage by I is equal to 0. And then yeah. Okay. Yeah, for sure. Oh, else break. Huh. I would recommend you to delete it here. Got it. And then don't print this. Okay. If you do return as, then you can print it. Oh, because I did not append it. Okay. Yeah, but yeah. I'm just gonna delete it, and you guys are supposed to figure out yourself. Okay, as a practice. All right. So yeah, and one comment that I will make is this question is extremely similar to the first question in the assignment. It is extremely similar. If you understand this question well, then you can easily do the first question in the assignment, which is prime, without without having to modify too much of your code. Okay, and I will also remind you that the order of output is this: 1, 10, 2, 5. So it comes in with pairs, you know, like think about the loop condition, that like how many times you loop. So this is like coming a little bit into algorithm analysis. Okay, I will talk about it more when I when I will do the when I review the answer tomorrow. And yeah, I'll teach you what the optimum way it is. Okay, so yeah, that is that. And also I find out, so as long since you guys sent me the code, I take a look and I can see the problem. Like the problem is, what the problem is that you don't really yet know the idea of return value. And you know, sometimes when you do a specific task, it does not return anything, right? It takes place in that variable, right? For example, like you do list sort, right? It takes place in that sort, in that list variable, instead of like as the return value. Because if the expression has some return value, then it can be printed. Otherwise, there's none, right? So there is no meaning for you to print it if the outcome is just none. Okay, so that is another comment that I'll make. So yeah, that will be the end of today's lecture. Is there anything else that needs to be mentioned before we end today's lecture? Yes, no, comments, thinking, anything? Okay, I will wait 1 minute and I'll wait until like 12:04, 12:05. If you guys have any questions, go ahead. If you guys do not,
then I'll just call it for a day. And in terms of the video, I'll just find it tonight and and I will show you guys tomorrow of like a short video introduction to object-oriented programming. Okay. All right. It seems like no one actually wants to ask questions. So yeah, that is it for today's lecture. I will see you guys on tomorrow 10 a.m. Okay. And yeah, tomorrow is Friday. Yay, happy Friday. All right. Got it. All right. I will see you guys tomorrow.
Thank you. Bye.
Yeah, bye.
Have a good day.
Have a good day. Yeah, and remember that the assignment is due tomorrow night. So yeah. All right, all right. Let's head out. All right, see you guys. Bye.